Hi there. Today we are running a realistic DevOps interview simulation focused on one of the most common and painful scenarios in our field. It worked in staging. It broke in production. This interview will test how you think about environment parity, configuration drift, hidden dependencies, data differences, and real-world debugging under pressure. Pause the video before each answer. Say your response out loud as if you are in a real interview. Then compare your thinking to the sample answer. If you find this useful, subscribe so you do not miss the next simulation. Let us begin. Warm-up. Behavioral questions. First question. Tell me about a time something worked in staging but failed in production. How did you handle it? A strong candidate might answer like this. I had a situation where an API service passed all integration tests in staging, but in production, it started returning intermittent 500 errors. My first reaction was not to assume the code was fine just because staging was green. I treated it as an environment discrepancy problem. I compared environment variables, database versions, and infrastructure configuration between staging and production. We discovered production had a slightly newer database minor version, and a specific query plan behaved differently under higher concurrency. The issue was not visible in staging because the load profile was lower and the data volume was smaller. I worked with the database team to adjust indexing and updated staging to better reflect production scale. The key lesson was that staging must simulate not just code paths, but also realistic data size and traffic patterns. Second question, how do you respond when a developer says, it works in staging, so it must be an infrastructure issue? A strong candidate might say, I avoid defensive reactions. Instead, I reframe the problem as shared ownership. If it works in staging but not production, that means there is a difference somewhere. The goal is to identify that difference. I usually start by asking structured questions. What is different between environments in terms of configuration, data, traffic, security policies, feature flags, or networking? I suggest comparing container images, environment variables, and runtime flags first. By making it collaborative and evidence-based, we reduce finger-pointing and focus on narrowing the gap between environments. Third question. Describe a time you had to improve staging to prevent production surprises. A strong candidate might respond, in a previous role, staging used smaller instance types and a shared database with limited data. Production used larger instances and a separate database cluster. We had repeated issues where memory usage patterns and query performance behaved differently. I proposed making staging more production-like. We provisioned similar instance classes using infrastructure as code. We anonymized production data and imported realistic datasets into staging. We also introduced synthetic load testing. It increased staging costs slightly, but we reduced production incidents significantly. That trade-off was worth it because reliability improved and deployment confidence increased. Core technical and scenario questions. First question. Why does something commonly work in staging but fail in production? A strong candidate might say, there are several categories of differences. Configuration differences are the most common. Environment variables, secrets, feature flags, or third-party endpoints might differ. Even a missing flag can change behavior. Data differences are huge. Production data is messy, larger, and more diverse. Staging data is usually clean and smaller. Edge cases often only appear with real data. Scale differences also matter. Concurrency, memory pressure, connection pool exhaustion, and timeouts may only appear under production traffic. Security and networking policies can differ too. Production might have stricter IAM rules, firewall rules, or rate limits. So when I hear it worked in staging, I immediately think, what dimension is different between environments? Second question. Imagine a deployment passed all staging tests. In production, it fails only under high traffic. Where do you start? A strong candidate might respond, I would first determine whether the issue is resource-related or logic-related. High traffic suggests concurrency, resource exhaustion, or timeouts. I would check metrics for CPU, memory, connection pools, thread counts, and error rates. If we see saturation patterns, that points to scaling or configuration problems. Then I would review auto-scaling settings. Are replica counts sufficient? Are HPA thresholds realistic? Are we hitting database connection limits? If infrastructure looks healthy, I would examine application logs and traces to see if specific code paths are triggered more frequently in production due to real user behavior. The key is to form hypotheses and test them systematically instead of guessing. Third question: how do you design environments to minimize the worked-in staging problem? A strong candidate might answer, environment parity is the foundation. Infrastructure should be defined using code, so staging and production are built from the same modules. Container images should be identical between environments. The only differences should be configuration and secrets. We should also mirror production topology where possible. If production uses multiple availability zones, staging should too, at least for critical components. Another important factor is realistic data and traffic simulation. Without production like load and data size, staging only tests correctness, not resilience. Finally, we need observability parity. If production has full monitoring and tracing, staging should too. That way, we can see problems before they reach users. Fourth question: suppose staging and production use the same container image, same infrastructure code, and same configuration templates, yet production still fails. What could still be different? A strong candidate might think out loud like this. Even if the declared configuration is the same, runtime conditions can differ. Production might have different kernel versions, underlying cloud hardware, or network latency to external services. Third-party dependencies might behave differently under production IP ranges or higher request rates. Rate limiting from external APIs is a classic example. Another difference is feature flag exposure. Maybe a flag is enabled for a larger audience in production. Also, user behavior patterns differ. Production users may chain requests in ways that staging tests never simulate. So I would expand the investigation beyond static configuration and look at dynamic behavior and external dependencies. Next question: you deploy a change. Staging was stable for days. In production, some users get 403 errors, but not all. What is your thought process? A strong candidate might think through it like this. Intermittent 403 errors suggest a permissions or authorization issue, not a total service failure. The fact that only some users are affected tells me it might be role-based access control, token validation, or a feature flag tied to user segments. I would first check whether authentication providers differ between staging and production. For example, staging might use a mock identity provider, while production uses a real OAuth provider. Token expiration times, audience claims, or signing keys might differ. Then I would look at IAM policies or service-to-service permissions. Production often has stricter rules. Maybe a new service account was not granted access to a downstream resource in production. I would also compare environment variables related to secrets. If the production environment has a different secret version or missing key, signature validation could fail for some tokens. The key is to focus on what dimension is different per user. Are they in different regions, different roles, different feature cohorts? I would narrow the scope before making any changes. The trade-off here is speed versus certainty. We could roll back quickly to reduce impact, but if the issue is configuration specific to production, we might not learn the root cause. I would assess user impact first, then decide whether to roll back or fix forward. Next question. Your application connects to a database. It worked in staging. In production, you see connection timeouts after deployment. No code changes were made to database logic. What could be happening? A strong candidate might respond, connection timeouts usually point to network rules, connection pool exhaustion, or database capacity limits. I would first verify whether the production database has the same max connection setting as staging. Often staging has lower traffic and never hits the limit, so connection leaks go unnoticed. Then I would check whether connection pooling configuration differs between environments. Maybe production uses more replicas, which multiplies the number of open connections. If each replica opens a fixed pool size, total connections can exceed the database limit. Another possibility is network-level restrictions. Production might use private subnets, NAT gateways, or stricter security groups. A misconfigured rule could cause intermittent connectivity. I would also compare latency. If production database is in a different region or availability zone configuration, higher latency could cause timeouts under load. The thinking process is to move layer by layer, application layer, network layer, database configuration layer, and infrastructure scaling layer. The uncertainty here is that multiple small differences can combine. For example, slightly higher latency plus slightly smaller connection limits can tip the system over only in production. Next question. Imagine you are asked to guarantee that staging is identical to production. Is that realistic? How would you approach that request? A strong candidate might answer thoughtfully, guaranteeing perfect identity is not realistic. Production has real users, unpredictable traffic, and evolving data. There will always be differences. However, we can aim for high fidelity. I would focus on infrastructure parity using infrastructure as code. The same Terraform modules or templates should provision both environments with parameterized differences. Container images should be identical artifacts promoted from staging to production. We should never rebuild images for production. Data is harder. We cannot fully replicate production data for privacy and size reasons, but we can anonymize and sample representative datasets. Traffic simulation is another layer. I would introduce load testing pipelines that mimic peak traffic patterns before production release. There is a cost trade-off here. Making staging fully production-sized can be expensive, so I would prioritize critical components. For example, database clusters and network topology should match production, while non-critical services might run on smaller instances. The goal is risk reduction, not perfect symmetry. Next question. You discover that staging runs on x86 instances, but production runs on ARM-based instances. The application works in staging but crashes in production. How do you reason about that? A strong candidate might think out loud like this. Architecture differences are significant. If the container image was built for one architecture and not tested on the other, binary compatibility issues can arise. I would first confirm whether multi-architecture images are being built. If not, production might be running emulated binaries or incompatible dependencies. Next, I would check whether any native extensions, such as database drivers or system libraries, behave differently on ARM. Some libraries may have subtle bugs or performance differences. This highlights the importance of environment parity not just at the application layer, but at the hardware layer. The trade-off here might have been cost optimization. ARM instances are often cheaper, but if staging does not match architecture, we introduce risk. The corrective action would be to align architectures or introduce multi-architecture testing in CI to ensure both platforms are validated. Next question. After a deployment, production latency increases by 20%. Staging benchmarks showed no regression. Metrics are green except user complaints. How do you approach this? A strong candidate might respond, a 20% latency increase might not trigger alerts if thresholds are set too high. So the first step is to validate whether monitoring captures user experience accurately. I would examine percentiles, not just averages. Perhaps P95 or P99 latency increased, but averages remained stable. Then I would compare resource usage patterns between environments. Production may have larger datasets, leading to slower queries. Another angle is cache behavior. In staging, cache may be warm due to limited traffic patterns. In production, new deployment might have invalidated caches, leading to more database hits. I would also look at external dependencies. If the application calls third-party services, production IP ranges may be subject to rate limits or slower responses. The uncertainty here is that small regressions can accumulate across services. Tracing can help identify where additional latency is introduced. The reasoning process is to treat staging as a partial signal, not proof of correctness. pause again and consider how you would answer these questions in a real interview. In the final segment, we will explore high-pressure judgment calls, where the correct answer is not technical perfection, but thoughtful risk management. These are not purely technical, they test judgment. First question: it worked perfectly in staging. In production, only 5% of users are affected. Revenue impact is small. Rolling back will delay a major feature launch that leadership has been pushing for weeks. Do you roll back or investigate live? A strong candidate might approach this carefully. I would first quantify the impact. 5% sounds small, but I need to understand who those users are. If they are high-value customers, the business impact could be disproportionate. Next, I would assess blast radius. Is the failure isolated to one endpoint or cascading across services? Is it degrading over time? If the issue is contained and there is no data corruption, I might choose to investigate while mitigating impact. For example, disable a feature flag or route affected traffic to a fallback path. However, if there is any risk of long-term damage such as inconsistent state, security issues, or growing failure rates, I would lean toward rollback. The maturity here is recognizing that ego and launch excitement cannot override user trust. A delayed launch is temporary. Loss of user confidence can be permanent. I would communicate clearly to stakeholders, present impact, uncertainty, and options, then make a decision aligned with risk tolerance, not pressure. Next question. A senior engineer insists the issue cannot be infrastructure because staging and production use the same Terraform modules. Meanwhile, users are still failing in production. How do you handle that conflict? A thoughtful answer might sound like this. First, I would avoid framing it as infrastructure versus application. Terraform modules being the same does not guarantee runtime parity. Variables, environment inputs, and external dependencies can differ. I would suggest we jointly verify assumptions. For example, compare actual deployed configurations in both environments, not just code definitions. This is about humility under uncertainty. Even experienced engineers can anchor to assumptions. If the discussion becomes heated, I would redirect to data. Logs, metrics, configuration diffs, traffic patterns. In parallel, I would ensure we are mitigating user impact. The debate can continue, but the priority is service restoration. A mature engineer protects relationships while protecting users. Next question. You discover that production and staging use different versions of a managed cloud service because staging was never upgraded. The difference likely caused the incident. Do you immediately align staging or stabilize production first? A strong candidate might reason this way. Stabilization comes first. Production is the source of truth for user impact. Once stable, I would align staging to production version, not the other way around, unless there is a compelling reason. Then I would analyze why version drift was allowed. Is there no automated upgrade strategy? Are we not tracking managed service versions in infrastructure code? The lesson is that configuration drift between environments is often silent until failure occurs. Fixing process is as important as fixing symptoms. Next question. It worked in staging because staging has much lower data volume. In production, a query that scanned thousands of rows now scans millions. You are under pressure to fix immediately. Do you optimize the query live, scale vertically, or introduce caching? A mature answer would acknowledge uncertainty. I would first reduce user pain. The fastest mitigation might be scaling the database or increasing replicas temporarily. While that buys time, I would profile the query in production. If it is inherently inefficient, throwing hardware at it is not sustainable. Caching might help, but only if the data access pattern allows it. If it is highly dynamic, cache hit rates may be low. The calm approach is layered. Short-term mitigation to protect users, mid-term optimization to address root cause, long-term architectural review to prevent recurrence. Under pressure, speed matters, but direction matters more. Next question. Leadership asks you to skip staging for a hotfix because staging has been unreliable and production is the real test anyway. What do you say? A strong candidate might respond carefully. I would explain that staging is not just a ritual. It is a risk reduction mechanism. However, if staging is unreliable, that is a separate problem. We should fix staging rather than bypass it. For a critical hotfix, we could consider a limited canary deployment in production. Roll out to a small percentage of users, monitor closely, then expand. This provides validation without fully skipping safety checks. Blindly deploying to production increases risk, especially when trust in staging is already compromised. The key is balancing urgency with discipline. We have covered technical gaps between staging and production, subtle configuration drift, architecture mismatches, data scale differences, and difficult leadership pressure scenarios. Take a moment to reflect. Which question felt uncomfortable? Was it the rollback decision under business pressure? Was it challenging a senior engineer's assumption? Was it admitting that staging cannot perfectly mirror production? In real interviews, your thought process matters more than perfection. Interviewers listen for structured reasoning, awareness of uncertainty, and user-centric prioritization. If you are preparing for DevOps, SRE, or platform interviews, practice answering out loud. Pause the video. Articulate your reasoning before listening to sample answers. Engineering maturity is not about knowing every tool. It is about making calm, informed decisions when systems behave differently than expected. If this format helps you prepare, subscribe for the next simulated interview. We will continue exploring real production scenarios that separate mid-level engineers from senior ones. And as always, reflect on how you would respond in your own environment. The gap between staging and production is not just technical, it is organizational, cultural, and human. I will see you in the next interview.